Hey everybody, welcome. Today I'm going to be showing you how to make dynamic UI elements, like this collapsible UI that I have here. You can use this same idea for creating things like a bouncing text box or a button that maybe runs away from your cursor. Alright, let's get into it. So I'm going to stop playing. I'm going to show a little bit of the hierarchy here. You can see that I have my main selection group, which is controlling this entire group of UI elements. One thing that I will note is that our button here is not a parent of the rest of this. The way that the UI system in Unity works is that if, let's say, the background image was a child of this button, it's going to transfer any click events to the button. Which in some cases, maybe that's what you want. You want to be able to click anywhere on it, and it will bring out and then collapse your UI. For my use case, it's not what I wanted, and so I just a reminder that if you run into that problem, that's how you fix it. Okay, so our first thing that we're going to do is we're going to remove this old script, and then we're going to make a new C# script. We're going to just call it. Go ahead and call it drawer manager. Okay, go ahead, let that compile, open that up. Okay, let's do some setup. We're going to remove update here. I'm going to remove this line just to make it a little bit easier to read, a little bit less noisy. And the first thing that we're going to do is we're going to create a set of serialized variables. So here they are. We're going to have a game object, which is going to be whatever the parent of the group of UI elements that you want to move is going to be. We're going to need two vector2s, which are our starting position and our ending position, or for the sake of this, we're actually going to start this as the closed position and the open position. And then we're going to want an animation curve. The reason that these are serialized fields is because I want to be able to edit them in this inspector, but I don't want other scripts to be able to access them, or at least I don't have the need to do that. Then we're going to want a collection of 3 just private variables, which are going to be a rect transform, a float, which is going to be called endtime, and then we want a bool, which is going to be called it's open. We're going to default that value to false. Now, the first thing that we're going to want to do is we're going to want to make a new private function. And what this is going to do is it's going to go through our animation curve, and it's going to tell us, okay, well, how long do we want the animation to last? And what we're going to call that is find furthest keyframe. Might be better to call this latest keyframe, something like that. Doesn't really matter. And what we're going to want to do to make that work is we're going to want to create a temporary float here called max time. And we're going to set it to the lowest number possible, which is -infinity. Then we're going to create a for each loop, because you might have the need to create more and more keyframes for your animation. Maybe you want it to spiral, you want it to do some crazy stuff. And so we just want to have the ability to have the scale no matter how many frames you decide to put in. And I'll actually show you a little trick here. If you have a for each and you press tab twice, it'll auto-complete it. For the variable type, we want to give it keyframe. And we are going to call this a frame in the collection of animation curve dot keys, which will return an array of all of the keyframes inside of it. Okay. Then inside of that for each loop, we want to create an if statement. We're going to say if the frame that we're looking at is at a time that is greater than the max time, we want to set max time to equal frame.time. So it's going to go through the first one. If it's greater than negative infinity, which it should always be, it's going to become the new max time. And it's going to go into the next frame. If the next frame has a time that is further along, it will override it, and so on and so forth. After we've gone through the entire for each loop, we want to say end time is equal to max time. Okay? Then we're going to want to call that function inside of our start. We're going to want to do some more setup, which we're going to set our rect transform is going to be equal to get component rect transform. And then this next step is optional, but what we're going to do is we're going to set our closed position, and for some reason I misspelled it, is equal to m underscore rt dot anchored position. Let's go ahead and fix that before I mess that up again. Oh, not like that. There you go. Okay. Next thing that we're going to want to do is we're going to make a public function, which is going to be our actual function that we call to open or close the drawer. And inside of it, so we're going to need to know if the drawer is open or if the drawer is closed in order to know what we need to do. So I'm going to say if is open, then I'm going to do something. If it's not open, we're going to do something else. Okay? Then we're going to make a routine. So we're going to make a private IEnumerator. This is going to be open routine. And there's going to be a pattern here that you've probably seen before. We're going to make a new float called elapsed time. We're going to set that to equal to 0 because it's going to happen right at the beginning of the routine. We want it to zero out the variable. Then we're going to create a while loop, and while our elapsed time is less than our end time, we're going to interpolate between the, in this case, the closed position and the open position. So the way that we're going to do that is we're going to set our anchored position to equal, sorry, not mathf, vector3 dot lerp, and we're going to feed our closed position going towards our open position, and we're going to interpolate using the value animation curve dot evaluate, and this is going to return the value of y at a given x position, and the given x position is going to be elapsed time. So at a certain time on the animation curve, what's your current value? That's what we're doing there. Then we're going to do a quick statement here, which is going to be you'll return new frame. So we're going to wait until the frame ends before we continue on. And then we're going to say elapsed time plus equals time that delta sign. So at the end of every frame, I want to add the amount of time that has passed since the last time into elapsed time, and then we're going to continue to go through this loop over and over again until elapsed time is equal to or greater than end time. After we've done that, because we're opening, we're going to set isOpen is equal to true. Okay. Now, we actually want to copy this routine, come down here and paste it. As you might imagine, we're going to make a close routine. Things that we need to do to change this are, well, if you're closing, isOpen becomes false. we're going to be, instead of going from closed to open, we're going to be going from open to closed. And then all we need to do is plug these in. So we're going to start coroutine. And if it's open, we're going to run the close routine. And if it is currently closed, we run open routine. All right, and that's all that you should need. All right, let's go back into the game. We're going to take our new script. We're going to put it on our parent object that we were talking about earlier. We're going to take that, we're going to put it into the drawer parent slot. For me, because in script I said that the closed position is going to be equal to the anchor position on start, I'm not going to set the closed position in the hierarchy. But the open position, we need to know where this is going to move to. For me, I know, actually, that the place that we want to move to is basically 0, 0, 0. So we're actually going to leave the open position as is. The closed position is negative 575. One more thing that we need to do is we need to set our animation curve. So we have a couple of different ways that we could go about this. You could do a linear opening to where the panel is going to be moving at the same speed the entire time. But what I actually want to do is I want to do an ease in. So it's going to go much faster when it starts, and then it's going to slowly come to a halt. Here, on the x-axis, that's going to determine how long our animation is. On the y-axis, it's going to determine how complete it is. So your y value should never go above 1. Your x value can be whatever you like. So our time is actually, I want to make it twice as fast. I want to make it 0.5 instead of a full second. Okay. And now that we've done that, we can go ahead and start it up. You can see that our closed position gets set to the current position, but there's going to be a twist where if we click on this button, nothing happens. Well, why is that? It's because we're not actually calling that toggle drawer function anywhere. So we're going to click on this button. As you can see, we have an on-click event already added here. This is what it's going to look like normally. So you add that. Well, we need an object. What are we going to put in there? Let's take the object that has our new script on it, place it inside. And for function, we're going to go to our script on the dropdown, and then we're going to go to our function called toggle drawer. Okay, simple enough. When we open up the game, we should see that when we click the button, it slides out and slides in perfectly. Okay, that's all, guys. If you enjoyed the tutorial, please like and subscribe. Drop a comment if you want to see anything else. I will leave a link to the game that I developed this inside of. It's a little idle city builder game. And yeah, see you guys next time.